Hi there, welcome back. Today we'll be looking at this problem, the best time to buy and sell in stock. The problem states that you are given an array of prices where price I is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot, return 0. Let's take a look at example 1. We have prices equal to 715364 and output is 5. How do we get the answer 5? The explanation is that we buy on day 2 where the price equals to 1, then we sell it on day 5 where the price equals to 6. So our profit is 5, and note that there isn't any other way where we can buy at a lower price and sell at a higher price to get a better profit than 5. And also note that we cannot buy where the price is 1 and sell it on day 7 because time is temporal going from left to right. And example 2 has prices equal 7, 6, 4, 3, and 1 and output equal to 0 because we cannot make any profit. Let's go to the whiteboard and see how we can solve this conceptually. So we're given an array where prices equal to 715364. And we know that the output of this, the answer should be 5, where it's the difference between this and this. So how can we solve this? The optimal solution for this problem is to notice that the goal of this algorithm is for us to sell at the lowest. Is to buy at the lowest and to sell at the highest. So to solve this problem effectively, we need to draw out the graph of the stock prices. So let's say 7's here, 1 goes up to 5, goes back down to 3, goes back up to 6, and comes down as 4. So we can see that in this graph, what we really need to do is simply to find the lowest point and the highest point after the lowest point. And we want to find the maximum profit. That would be the difference between these 2 points. What we can do here is we can scan the array from left to right, and as we go from left to right, we'll take note of the smallest element so far. If the current element is bigger than the smallest element so far, we'll simply calculate the difference between that and see if it's greater than the maximum profit. If it is not, then the current element would be the smallest element so far. So it looks something like this. If the current element is smaller than the smallest element so far, then the smallest element so far equals to the current element. Else, if the current element minus the smallest element is greater than the profit so far, then profit equals to current element minus smallest element. And in the end, we simply return profit. We can see that this algorithm has a time complexity of O of n, as we're only going to scan through the array once from left to right, and the space complexity would just be O of 1 because we're only using variable names to keep track of numbers. So let's go back to the code and see how we can code this out. To begin with, we need to initialize a variable that represents the smallest price so far. So let's give it the name smallest, which equals to prices 0 and the profit, or the maximum profit equals 0 in the beginning. Now we need to loop through the array. So we have for prices. If the price that we're looking at right now is less than the smallest price so far, then the smallest price equals to price. Else, if price minus smallest so far is greater than the maximum profit, the maximum profit would equal to price minus the smallest price so far. And then in the end, we simply return maximum profit. So let's run this code, see it passed, and submit it. And we pass all the test cases. So that's it for this problem. Thank you for listening. I'll see you next time.